In this question we are given that a particle is moving in the xy plane and the movement is given by the parametric functions x of t and y of t, where y of t is given by this chart and x of t is given by this, the derivative is given by t squared plus sine of 3t squared. And we are given the initial position of the particle at time equals 0. And the first question is find the position of the particle at time t equals 3. So let's find x coordinate and y coordinate. X of 3 is equal to x of 0 plus integral from 0 to 3 x prime of t dt. And this is by the fundamental theorem of calculus. Let's plug in the values. X of 0 is 5 plus integral from 0 to 3 t squared plus sine of 3t squared dt. And we need to use a calculator to calculate that. And then y of 3 we can just take off the chart, and this is this point here. Y of 3 is equal to negative 1/2. So the point will be whatever we calculate here using the calculator, comma, negative 1/2. And let's do that next. So let's calculate this position, and the x coordinate is 5 plus integral from 0 to 3 of the function t squared, which is, we do x squared, doesn't matter as long as we use the same variable, plus sine of 3 times x squared, close parentheses, dx. So this gives us the x coordinate, which is 14.377 thousandths, and y coordinate we said is negative 1/2. So the coordinate of the position of the particle at time t equals 3 is 14.377 thousandths and negative 1/2. In this question we need to find the slope of the line tangent to the graph of the particle at t equals 3. And so the slope is equal to y prime at point 3 divided by x prime at point 3. So it's usually the derivative dy over dx, or in this case it's actually dy over dt divided by dx over dt. So what is y prime at point 3? It's a slope to the graph here at the point 3, which is rise over run will be 1 over 2, so this is equal to 1/2. And then derivative at point 3, we just need to plug in 3 here, which will be 3 squared plus sine of 3 times 3 squared. And so let's use a calculator to calculate that, and that will give us the slope at point t equals 3. So let's calculate the slope. It's 0.5 divided by open parentheses the derivative of x at point 3, which is 3 squared plus sine of 3 times 3 squared, close parentheses, close another parentheses. So this will give us the derivative, and so the derivative is 500ths, rounding up to a thousandth. This is either 50 thousandths or 500ths. In this question we are being asked to find the speed of the particle at time t equals 3. And so speed is equal to, by Pythagorean theorem, the square root of the velocity in one direction, so x prime at point 3 squared, plus velocity in the other direction squared. And so as we said in the previous question, the slope, the velocity is given by this function, so we just need to plug in 3 there, and then y prime at point 3 is equal to 1/2. So let's plug in those values using the calculator and find the speed at time t equals 3. So let's calculate this now, and it's square root, in parentheses, plugging in 3 into the expression for x prime will give us 3 squared plus sine, in parentheses, 3 times again 3 squared, close parentheses, and close another parenthesis, squared, plus, in parentheses, negative 0.5 squared, and this should give us the speed at time t equals 3. So the speed is 9.969 thousandths. That is the speed of this particle at time t equals 3. In this question, we are being asked to find the total distance traveled by the particle from time t equals 0 to time t equals 2. And so total distance is equal to the integral from 0 to 2 of the speed of the function as a function of t dt. And so in this case, this is equal to integral from 0 to 2 square root of x prime of t squared plus y prime of t squared dt. And so y prime of t is actually changing on this interval in a predictable fashion. So we can break this into two integrals, integral from 0 to 1, and then instead of x prime of t we just plug in this functional form, not writing it out right now, x prime of t squared plus, and then the derivative of the slope of this function between the points 0 and 1, which is in this case rise over run, and again rise is -2 and run is 1, so it's -2 squared dt plus another integral from 1 to 2 square root of x prime of t squared plus, in this case, the y prime is 0 squared dt. And so let's use the calculator to calculate this expression and this expression and add them, and to get the answer for the total distance traveled by the particle from time t equals 0 to time equal 2. Let's do that next. Let's calculate the sum of these two integrals now, and so we go to mathematics, integral, and the first integral is from 0 to 1 of the function square root of, in parentheses, we have x squared plus sine of 3 times x squared, close parentheses, close another parenthesis, squared, plus, in parentheses, -2 squared dx, plus another integral, mathematics, integral from 1 to 2 of the square root, in parentheses, x squared plus sine 3 times x squared, close parentheses, close another parenthesis, squared, plus, in this case 0, plus 0 squared, and again with respect to x. And so sum of these two integrals will give us distance traveled between time equals 0 and 2. And so the distance is 4.350 thousandths. And so this is the answer. Thank you, and I will see you in the next video.